Welcome to Creative World. In this video, we will solve Chapter 1 exercise problem number 44. While solving this problem, we will be using electrical power formula, that is the product of voltage and current, and Tellegens theorem. According to Tellegens theorem, power supplied to a network is always equal to power consumed by the elements of that network. And if we add these two powers, their result will be 0. We also will be using passive sign convention theory. According to this theory, elements with negative power will be considered as power supplier and elements with positive power will be considered as power absorber. First, read the scenario, calculate the power absorbed by each element in circuit, also verify Tellegens theorem. In this circuit, we have to calculate the power of each element and also confirm the Tellegens theorem using that calculated powers. So without wasting time, let's proceed towards the solution. This is the circuit and we have to calculate and identify supplied and absorbed powers in this circuit. First, we will calculate power of all elements and then we'll justify Tellegens theorem using that calculated powers. Start with element 1. Voltage across element 1 is 12 volt and current through it is 2 ampere. This current is entering from positive terminal, so this current will be taken with positive sign. Power of element 1 will be 12 multiplied by 2, that is 24 watt. Because of positive sign, this power is being absorbed by element 1. Next is element 2. Voltage across element 2 is 6 volt and current through it is 4 ampere. This current is entering from negative terminal and leaving from positive terminal, so this current will be taken with minus sign. Power of element 2 will be 6 multiplied by minus 4, that is minus 24 watt. Because of minus sign, this power is being supplied through this element 2. Next is element 3. Voltage across element 3 is 6 volt and current through it is Ix, that is 2 ampere. This current is entering from positive terminal and leaving from negative terminal, so this current will be taken with positive sign. Power of element 3 will be 6 multiplied by 2, that is 12 watt. Because of positive sign, this power is being absorbed by element 3. Next is element 4. Voltage across element 4 is 9 volt and current through it is 4 ampere. This current is entering from positive terminal, so this current will be taken with positive sign. Power of element 4 will be 9 multiplied by 4, that is 36 watt. Because of positive sign, this power is being absorbed by element 4. Next is element 5. Voltage across element 5 is 24 volt and current through it is 2 ampere. This current is entering from positive terminal and leaving from negative terminal, so this current will be taken with positive sign. Power of element 5 will be 24 multiplied by 2, that is 48 watt. Because of positive sign, this power is being absorbed by element 5. Now moving towards the power of sources in this network. This circuit contains two voltage sources. For our understanding, we will label them as voltage source 1 and voltage source 2. We will start calculating power from voltage source 1. Voltage across voltage source 1 is 24 volt and current through it is 4 ampere. This current is entering from negative terminal, so this current will be taken with minus sign. Power of voltage source 1 will be 24 multiplied by minus 4, that is minus 96 watt. Because of minus sign, this voltage source 1 is supplying power to the network. Next is voltage source 2. Voltage across voltage source 2 is 15 volt and current through it is 4 ampere. This current is leaving from positive terminal and entering from negative terminal, so this current will be taken with minus sign. Power of voltage source 2 will be 15 multiplied by minus 4, that is minus 60 watt. Because of minus sign, this voltage source 2 also supplying power to the network. Next is current source. Voltage across current source is 12 volt and current through it is 6 ampere. This current is entering from positive terminal and leaving from negative terminal, so this current will be taken with positive sign. Power of current source will be 12 multiplied by 6, that is 72 watt. Because of positive sign, this current source is absorbing power of 72 watt. Last element of the circuit is current controlled voltage source. Voltage across this current controlled source is 3Ix and the value of Ix is 2 ampere. So the voltage across this dependent voltage source will be 2 multiplied by 3, that is 6 volt, and current through it is 2 ampere. This current is entering from negative terminal and leaving from positive terminal. So this current will be taken with minus sign. Power of this dependent voltage source will be 3 multiplied by 2 multiplied by minus 2, that is minus 12 watt. Because of minus sign, this dependent voltage source is also supplying power to the network. Now at this stage we have calculated and identified all supplied and absorbed powers in this network. We can use Tellegens theorem and justify the Tellegens theorem implementation on this circuit. We know the basic formula of Tellegens theorem is if we add power supplied and power consumed of a network, their result will be 0. Place all the supplied powers and absorbed powers of this network in this equation. If we add these values, these all power supplied will be minus 192 watt and these all absorbed powers will be plus 192 watt, and if these two add together their result will be 0. At this stage Tellegens theorem is justified using all supplied and absorbed powers of this network, and it is proved that if we add all supplied and consumed powers of a network together their result will be 0. So this was chapter 1 exercise problem number 44. Thank you. See you again in next video.